Hi friends, now we are going to discuss about shells and subshells. Now, shells. What is meant by shells? Electrons evolve around the nucleus. For example, this is a diagram of an electron. Nucleus, you imagine. Protons and neutrons are present inside the nucleus. You can imagine like this. And then electrons are evolving around the nucleus in a circular path. So, electrons are evolving around the nucleus in a circular path. That circular path of an electron, we are calling as orbit. We are called as orbit. These orbits we are also called as shells. How the planets are evolving around the sun? The same way here electrons are evolving around the nucleus, we are calling. And we know already nucleus is having a positive charge, and here protons plus indicates fundamental particle, that is proton, which is having a positively charged particle present inside the nucleus. And here 0 is there, no? This 0 we are calling as a neutron. This is a no charge, fundamental particle without charge, that we are calling as a neutron. And protons and neutrons together we are calling nucleons. And we know the mass number of protons is equal to number of neutrons, so that mass number is also called nucleon number. We have some idea, basic idea about that. Mass number is also called nucleon number because the protons and neutrons both are present inside the nucleus. So we are calling these both as a nucleons. That is the reason we can also call them as a nucleon number. Next, another one, subshells. What is meant by this subshells? Subshells are also called orbitals. Subshells are also called orbitals. And these orbitals are having electrons. These orbitals contains electrons. Even we can say the maximum probability of finding an electron, we can say it as orbitals. Okay, orbitals. And here we have 4 types of orbitals: s orbital, p orbital, d orbital, and f orbital. We can say s orbital, sharp orbital actually we can say, and this is in spherical shape. P orbital, this is principal, we can say principal, and p orbital will be dumbbell in shape. And d orbital we can say diffusion. Just like shortcuts we can remember this one. And the shape of the orbital, double dumbbell shape. Shape of the orbital will be double dumbbell shape. And f orbital we can say it as a fundamental. And then the shape of the structure will be complex structure, we can say. F orbital, complex structure. And then here, how can you say about these orbitals? First, like each orbit is associated with some energy, associated with some amount of energy, we can say some amount of energy, right? So hence these orbits are also called energy levels. Hence these orbits are also called energy levels. These orbits are also called energy levels. Energy levels. Remember this one, children? Don't forget. So now we can say orbit are also called shells, and these shells are having orbital are also called subshells, and these subshells or orbitals will have electrons. We can say electrons, okay? And these electrons are attracted towards the nucleus, and they will gains the energy. They will jump from one shell to the another shell, and then they will form a specific type of bond formations. That is called, like, the energy associated with the energy levels increases with the increase in the n value. So now I drawn a diagram. See, now here we have here actually, see, this is the center of the nucleus of an atom. Center of the atom, we can say. So here, when electron is evolving, it is forming like an orbit. This is called orbit, okay? And here, these orbits, we are also call this as a principal quantum number. This we can also call it as principal quantum number, indicates with small n, indicates with small n. So now you see here first shell is there. This is what actually nucleus is also called in Latin language kernel. So that is the reason we started with K alphabet first. And then here principal quantum number 1, that so n is equal to number of shell. Then this is the first shell. We have here s orbital. S orbital can accommodate, I will show here once again. S orbital can accommodate, S orbital can accommodate 2 electrons. P orbital can accommodate 6 electrons. D orbital can accommodate 10 electrons. F orbital 14 electrons. This is the maximum capacity of an electrons. These can be stay in the orbitals. Okay. So now, for example, if you are considering n is equal to n, what I said, principal quantum number, right? So principal quantum number n is equal to 1 we will take. So that is which shell? K shell contains only one s orbital. Only one s orbital. So just now I gave here explanation. S orbital can accommodate with 2 electrons, right? So here one s orbital, in the sense the number of electrons can be accommodated in K shell is 2 electrons. Then you consider n is equal to 2, means principal quantum number of shell n is equal to 2. Then we are saying this as L shell contains, second shell. So this indicates the number of shell, here 2, and then 2 s orbital and 2 p orbitals. So now 2 s orbital means how many electrons it can accommodate? 2 electrons plus p orbital 6 electrons. So total should be 8 electrons. More than that not possible in the L shell. Okay. So now next, and number of shell. This is the principal number of shell is a third shell. If we are considering third shell, we are involved, third shell we are calling as M shell, and here we can say third orbit, right? This is third orbit, so we can say third shell. Third shell means 3 orbitals will be there, 3s, 3p, 3d. So now s orbital we can say as a 2 electrons plus p orbital we can say it as a 6 electron, and d orbital we can say it as a 10 electrons. So total number of electrons can accommodate in third shell is 18 electrons. 2 plus 6, 8. 8 plus 10, 18 electrons, right? And then n is equal to 4, number of fourth shell. Then n is equal to 4. We can say this is n shell. Here N shell in the sense we can say 4 s orbitals, 4 p orbital, 4 d, and then 4 f orbitals. So now you can consider s orbital can accommodate 2 electrons, p orbital can accommodate 6 electrons, d orbital 10, plus f orbital 14 electrons. So total how many electrons we can say? 32 electrons. So then the maximum number of electrons are accommodated in N shell, that is 32 electrons we can say. The maximum number of electrons we can say as 32 electrons. So based on this, the number of shells we can say here. Okay. So if you are remembering this, then easily you are able to write the electronic configuration. So now we are going to discuss about the another one. See here, like we are discussing here, like node column we can say number of electrons. You can say here number of orbital, like n is equal to what I said? Number of shell. So n is equal to number of shell, then number of orbitals present in the number of orbitals, we can say it as a n square. For example, n is equal to 1 you take, n is equal to 1 you take. So 1 square. So how many orbitals can accommodate? 1 square means only 1 orbital only we can say. And you take n is equal to 2. That means 2 square you take. Number of orbitals can accommodate. This is actually like n is equal to 2 we are taking here. So 2s and 2p. So total 4 orbitals we can say. That is actually number of shell. And then n is equal to 3 you take. Next, number of electrons. This is actually very important. Children, you should remember this one definitely. Number of orbitals means that is actually where what we can say in orbitals, that is electrons. We can say it as a formula 2n square. So 2 is equal to the first shell you take 2 into 1 square. So means 2 into 1 is equal to number of electrons, 2 electrons. Then you take the second shell 2 into 2 square, 2 into 4. Then the second shell, this is actually we can say n is equal to number of shell, right? So n is equal to 2 we can say. Then n is equal to 3. Third shell you take. Third shell when you are considering here 2 into 3 square. So then 2 into 9 is equal to how many electrons? 18 electrons. Then n is equal to 4 you take. 2 into 4 square. So means 2 into 16. 32 electrons can accommodate here. So based on this formula 2n square, we can find the number of electrons are present in the subshells. Each subshell we can find it. So based on this one, we are going to find about the electronic configuration. So now here we are going to see, for example, when an electron is absorbs energy, it jumps from a lower energy level to a higher energy level, and by emitting the energy, it jumps from a higher energy level to the lower energy level. So this absorption and emission takes place in the form of electromagnetic radiations. Electromagnetic radiations, and here always electron when gaining the energy it will jumps from one place to the another place. And here just now I explained number of orbitals are there. I will show you that. Like for example, you take here s orbital spherical in shape, I said, right? S orbital spherical in shape, right? No? So s orbital, this is s orbital. What shape we can say here? Spherical in shape. And then when you are considering p orbital will have the 3 suborbitals are there in p orbital. 3 suborbitals. Actually p orbital can accommodate 6 electrons, right? So here we can say p orbital in case of a diagrammatic representation, you can say like this: px suborbital, py suborbital, pz suborbital. So according to the filling of electrons, you can say Pauli's exclusion principle, Hund's rule, Hofbauer principle. So electrons will be in the always filling with increasing order of their levels. So like that, we can, like this, we can fill the electrons in p orbital, and d orbital will have how many electrons? I said d orbital 10 electrons. So here d orbital having a p, actually I forgot, p orbital shape is a dumbbell in shape, like this it will be. So we can say px, py, pz. This is px, py and pz. The same when you are considering, the shape will be like this. And when you are considering the d orbital have 5 suborbitals. 5 suborbitals. Each orbital fills with 2 electrons each. Okay. So here take 1, 2, 3, 4 and 5. So dxy, dyz, dzx, dx square minus y square and dz square. These are the 5 suborbitals. 1, 2, 3, 4, 5 and then 6, 7, 8, 9, 10. When you are writing the electrons, always electrons we have to mention in the opposite spins only. You should not mention. Okay. So now here total number of electrons is 10. And here 5 suborbitals are there. Each suborbitals will fills with 2 electrons. So then 5 2s are how many electrons? 10 electrons we can say. Okay. I hope everyone understood about these shells and subshells and orbitals. In the next video, I will show you how to write the electronic configuration. Thank you all.